This is objective 1.1. Find the domain and range of a relation. This is from August 14th. First, we'll start out with what a relation is. A relation is any set of points or x and y values. Those mean the same thing. A set of points is the same thing as a set of x and y values. There are a couple of ways that we can write a relation. One of them is as a list of ordered pairs. Remember that an ordered pair is x comma y. So our list of ordered pairs, and I'm just going to make this up here, maybe -2 comma 3. Another one might be 0, 1, 2, -1, and maybe 3, 4. That's a list of ordered pairs there. And to indicate that they all go together as one relation, I'm going to put brackets around them, like that. You could use square brackets if you wanted to, but the curly brackets are the technical way to do it. The other way to display that same set of information is as a graph. So I can take each of these points and plot them on this graph here. -2, remember this is our x-axis and our y-axis. -2, 3 would be right here. 0, 1 would be right here. 2, -1 would be here. And 3, 4 would be here. That's the same set of information, the same relation displayed as a list of ordered pairs and as a graph. What we're more interested in, though, is the domain and range of the relation. So the domain of a relation is all of the x values. And the range is all of the y values. It's basically a fancy way of saying x and y. If I'm given a relation, in this instance displayed as a set of points on a graph, you can tell me the relation as a list of ordered pairs and the domain and the range. So here it says, write each relation as a set of ordered pairs, then list the domain and range. We can do that. For this one, I'll just list each point. -2, 2. -1, -5, 1, 4, and 3, 1. Again, to indicate that they all go together as one relation, I will put them in the brackets. Now I'm going to list the domain and the range. For the domain, I'm just going to go through and pick out each of the x values. So -2, -1, 1, and 3. For the range, I'm going to pick out each of the y values. 2, -5, 4, and 3. You can do the same thing over here. Each of these points are -1, 3, and -1, -2. 2, 4, and 4, 0. Put them in the brackets, then indicate the domain and the range. The domain in this case is -1. There's another -1 here, but when you're writing out a domain and range and you see one element repeat itself, you do not write it twice. So I only write one -1. Then I jump to the 2 and the 4. For the range, 3, -2, 4, and 0. 3, -2, 4, and 0. We can do the same thing when we have a line instead of a series of points. The arrows on any line means that this line extends in both directions forever. which means that the domain, all of the x values, goes on forever as well. We see that we have 1 is in the domain. That's an x value that's on this relation. We see 2, 3, 4. We know that this would extend to 5, and we know that it would extend all the way out to 100 or 200 or 1,000 or 1,000,000. Same in the negative direction as well. Well, the way we write that is by saying all real numbers. All real numbers. Because this extends horizontally in both directions, all of the x values, all real numbers, are contained in the domain. What about the range? Well, looking at this, we can see that there's only one y value that this relation ever touches, and that's here at 3. Doing the same thing on our examples, we see that the domain here is all real numbers. And if you want, you could write all reals as well. And the range is -1. Here, things change a little bit. Because the line is vertical this time, if we look horizontally, there's only one element of the x's, or of the domain, that the relation ever touches, and that is 2. So the domain is just 2. But the range this time extends up and down forever, so this is all reals. Same as all real numbers, just a shortened way of saying it. For example, number 5, things are a little bit different. The line extends up and down forever and side to side forever because it's tilted, which means that both the domain and the range are all real numbers. Moving on to the next ones. Here, again, we're going to list the domain and the range. The domain, I like to just go through and look and see if there's any dots or any line at -5 as an x, and there are not. There's nothing at -4, nothing at -3, nothing at -2, but when I get to -1, I see that there are dots at -1. So I write that as one of my elements of the domain. There's nothing at 0, there is something at 1, and there is something at 4, again here. For the range, I do the same thing, except on the y-axis. I see -3 has a dot, 2 has a dot, and 4 has a dot. Notice that I did not repeat the 2 or the -1 because you only write it once. Same thing here, domain and range. 1, 2, and 9. That's just pulling the x values out of that list of ordered pairs. The range, I see 2, -4, and there's another 2, but again, I do not rewrite it. I just leave it like that. If you're interested in the challenge, the domain here is all numbers that are bigger than -2. The line starts here and continues in this direction forever. So we'll say all x's that are greater than or equal to -2. And the range would be all y's that are greater than or equal to 1. You won't have a question like this on the quiz, but all the other ones will be.